All right, let's review ways we know how to synthesize amines already. One way is to take some alkyl halide, we'll say Rx for now, and we'll treat it with some cyanide in an SN2 type process. So we'll put this with a polar product solvent, and we'll end up getting our nitrile, which then we can reduce using lithium aluminum hydride and water. Although we will need the excess of that lithium aluminum hydride, we will end up making an amine. Notice, of course, we have one additional carbon if we follow this route. So if you want to make an amine, you can do it by using a nitrile, which will add one carbon to your molecule. We've also seen in that same chapter how to take carboxylic acids to turn those into amines. First, you'll want to make an amide. Generally, you'll want to first make that into the acid chloride, because making it with the acid, like I said, is extremely slow and terrible. So don't ever do it. You can use a couple equivalents of ammonia. Then after turning it into the acid chloride, that'll get you to the acyl chloride followed by the amine or amide, now that we've used our ammonia there. And then if we go ahead and again adopt excess lithium aluminum hydride and a water wash, we can end up getting our amine out. Notice that this one, number of carbons is the same from start to finish. So however many carbons you've got in your original molecule will still be the same at the end. So you can use a carboxylic acid. We've seen so many ways to make carboxylic acids. We make them from primary alcohols, from aldehydes, from all of our other carboxylic acid derivatives. We can turn these into amines. Any alkyl halide can be turned into an amine using a cyanide. And of course, if we have a benzene, we can use nitric acid and sulfuric acid, followed by some reducing agent, and then typically a base. You'll end up with your amine. And now we're going to introduce one more variant of this, which will allow us to do this in the presence of more sensitive functional groups. If we use, instead of zinc in HCl or iron in HCl, if we replace that second step with tin 2 chloride and acid, we'll be able to selectively reduce the nitro group in the presence of a carbonyl. So that was one thing we ran into earlier. So this will prevent that. We can reduce the nitro in the presence of a carbonyl. So, for example, if we have handy-dandy benzene, and it's got a ketone on it, let's say, if we go ahead and want to put an amine on this, as we know ketones are meta-directors, if we treat this with the same three that we did before, and I'll just copy that. Technically speaking, we're going to end up probably reducing our ketone as well. So we will end up with our amine, and we will end up probably with an alcohol up here. However, if we replace that second reagent with the tin chloride instead, see what we can do here with the arrows. There we go. If we treat that with tin chloride and acid, in our second step, we will preserve that ketone, and we will still get our amine meta to it. So we'll be okay there. So it just prevents it, because if we don't want the alcohol up on that other carbon, then we would have to oxidize it again. So that would add extra steps. Alternatively, we can use the tin chloride. The problem is zinc is kind of okay, not really environmentally disastrous, but tin is. So we try not to use tin too much, but if we're in the interest of making the amine in the presence of our carbonyls, we'll have to use it. Note, of course, this seems to be a pretty common misconception. These reactions, the nitric acid and sulfuric acid, this only works for benzene and other aromatics. We can't do this with regular carbons. So this only works for aromatics. So we can only use these reactions on aromatic species. We cannot, these other reactions won't work on aromatics. I mean, I guess the carboxylic acid one will, that's not a problem. But for example, KCN, we can't do an SN2 on an aromatic compound, right? We would need to, use some sort of aromatic substitution, nucleophilic aromatic substitution instead. So we can't do SN2 specifically. So just keep in mind, aromatic reactions and non-aromatic reactions should be kept separately in your brains. So these two generally used are for non-aromatic things not directly attached to a benzene. This set of reagents to install an amine on a benzene is for aromatics and aromatics only. You cannot use these reagents on non-aromatics and expect to get the same functional groups out. Okay, in the next couple of videos, we'll look at some easy ways to put on amines and some troubles with making some amines as well. So we'll look at that next.